Good morning, everyone. Can you all hear me okay? Thanks, guys. Uh, Give me just a moment and we'll get going with the lecture. But how are the demijohns looking? How are the plans coming along to get the wines cleaned up and bottled? I'd love to hear how you're all going. Uh, that's good to hear. Thanks, Luke, Rebecca, Ernesto. Yeah, the on your point there, Ernesto, with looking a little reductive. So carried out your instructions last week with the SO2 and tasted it at the same time and carried out an analysis. And the tasting here was just a tiny bit reductive as well. But just for your interest, the pH was 3.41. And we think it had just started malolactic fermentation because there was a very slow stream of those, those perfectly round bubbles showing up at the top of the tank. So we think it had just started malo, and the TA was 7.6. So yeah, in terms of acidity, was looking pretty good and tasting pretty good too. And then interestingly, the colour, even though we had racked it reasonably early, it had bounced back a little bit. It had nuances of hot pink rather than partridge eye. So I think it picked up a little bit more colour than what you guys were probably thinking would happen. But I've got some photos which I'll post after this class. But okay, on with the class. So today we're going to talk about filtration, which in terms of the subjects that we move through, only leaves bottling for next week and then a recap for the week after that. So we're in the home stretch now. So hopefully your conceptual understanding of the process has come a long way, and the way we talk about wines is a little clearer. So let's start off with some of the rationale for filtration. So to start off with, we'll go through the rationale, then we'll go through different kinds of filtration techniques later on in the lecture. So yeah, to start off with, we're looking to separate insoluble particles from the wine. So examples of insoluble particles might be grape matter, might be tartrate crystals. Then we're also looking to remove partially soluble particles. So we'll cover that in a little bit more detail as we move through the lecture, because this is the essence of this topic in a way, is that we have to stop probably thinking about things as being completely in solution or completely out of solution. Other rationale include improving the aesthetics of the wine and improving the microbial stability of the wine for bottling, improving the sensory character of a wine. So quite often we find that a wine tastes very, very different after filtration as well, and also to improve the shelf life of the wine, which to some extent is a rationale that summarises the points above. Okay, we'll move on to the next slide. Okay, so to start off with, let's look at some of the factors that influence the need for filtration. So the main driver, I guess, of the cloudiness or turbidity, stop making up words, of a wine, it relate directly back to the grape composition itself. So what we find is that in very good disease-free seasons, we have very limited interaction between microflora on the exterior of the grape and the grape juice on the inside, and as a result of that, we have a lower level of enzyme interaction and a lower level of formation or degradation of juice compounds. And to some extent, that's probably the biggest influence that happens very, very early in the winemaking process. Yep. Other factors that we need to consider are the desired wine style. So any wines that would have a residual sugar level, say probably greater than 5. Well, I guess the other thing is when we talk about SO2, we always think about that in relation to pH. But when we talk about residual sugar, we should probably think about that in relation to alcohol as well. So where we have a high residual sugar and a low alcohol, there is substantial opportunity there for microbial spoilage, so the desired wine style is very important when we talk about filtration, because there are some wines that, to remain as we intend them to be, require filtration, no question. And then there are other wines where filtration is not really a factor in achieving the desired wine style if the rest of the winemaking process has been geared towards achieving that style. Next is the winemaking process itself. So, how extractive is the equipment that we use? So, if we're using old, highly macerating pumps and, say, for example, a bag press with a very small screening area, or anything that would require any process that has a greater extractiveness to it, that's going to influence filtration and filterability. The cleanliness of our rackings. Have we attempted to rack a wine or a juice extremely cleanly, or have we taken solids along the way? That they're the sorts of inputs in the process that would impact upon the topic of filtration for that particular wine. Next, finally, and probably most importantly, is consumer expectations. What do people want from that product? Okay, so let's start off with the compositional factors. So presence of molds, mildews, and bacteria. So what we find is that there are a large number of what we call macromolecules that are the result of bacterial and mold and fungi processes. And by macromolecules, what I mean are molecules that are at one particular grape composition partially stable in solution. And by that I mean you might look at the wine and you might look at a turbidity reading. So a turbidity is a measure, if you like, of how cloudy the wine appears, and we can then make an approximation of how clean that wine is, if you like. And the influence that these molds, mildews, and bacteria have is they quite often produce large or high molecular weight compounds that don't cause any refraction when we measure it, the turbidity. So in other words, the wine looks clean, but when we come to filter the wine, these large molecular weight compounds interfere with the filtration of the wine. So that's a significant impact. And one way that we might seek to head that off, for example, is early on in the winemaking process, we would seek to start attacking those compounds. So, for example, at reception, we might use enzymes to attempt to break down those large molecules. So, processing enzymes very early on in the process might assist in breaking down those larger macromolecules to start off with. The next thing we might look to do is rack the juice very, very cleanly, and in this way we can increase the filterability of our wine at a later point. And the downsides of all of this, of course, are we might lose some of the benefits of contact with those solids, but we would increase the filterability. And like with everything in winemaking, we're just looking at the trade-offs between those two scenarios. Do I want a wine that will clean up easily, or do I want the benefit of flavours that might come from those solids? But on that topic, I suppose any fruit that is diseased is unlikely to have a positive flavour impact. So generally, if you're working with diseased fruit, you would seek to remove we would seek to move the wine or juice off those solids reasonably quickly. Moving on now to harvest BOMA PHTA and anthocyanin readings, which is a measure of our colour and tannin compounds in our juice and wine. These also have an impact on filtration as well. Pardon me, it's just a tick having a drink. Okay, so our BOMA PHTA, what these are essentially giving us is the key makeup of our solution. So how much alcohol will there be? How much acid is there? And what we find is that when any one of these parameters change, solubility of these macromolecules change as well, and that's key. That's sort of key to understanding the topic of filtration. So many of these large macromolecules might be made up of colloids that have a positive or a negative charge that are interacting with each other. And when the pH changes, the way those compounds interact also change. And likewise, when the alcohol levels change, the way those compounds interact with each other changes. So fundamental to all of this is understanding, how much is dissolved in what. What we find to start off with is that ethanol is an incredible solvent. And so things readily dissolve in ethanol, but equally ethanol is a very strong and aggressive compound in terms of degrading things like proteins and so on. So that can cause those macromolecules to break up as well. So we've got all these positive and negatives associated with high and low alcohol, and equally with pH as well. We find that we have a higher, we might have more cations at a low pH, but equally at that low pH, we might find that our ability to react them out with other things is also reduced. So we going into filtration, we have to be confident that the wine is the way that we want it to be. So we shouldn't be seeking to bring about any sudden change in composition prior to filtration. And it's for that reason that in last week's topic, I talked about the need to achieve the sensory objectives for the wine, prior to fining to that and stabilization. And so what we're doing now is we're moving on to a very late final stage in the winemaking process, where we really can only handle very subtle compositional changes. Because if for example we brought about a large compositional change now, that might not have been addressed at the fining stage. So we might find that we add a large amount of acid at this stage now, and for sensory reasons, and all of our fining efforts from the previous step have been undermined by that late addition. So the idea is, this is where, to some extent, the sequence is important. The ripeness of skin, seeds and pulp. So I sort of talked about that early on in terms of the cleanliness of the fruit. Okay, some details in terms of the winemaking process itself. So one of the themes of this subject has been the importance of time as an ingredient, and the duration of the maturation process is a great summary of that, if you like. So what we're talking about is all of those chemical and physical processes that are taking place during maturation are, creating a relatively stable solution. So all of the things that are going to flocculate over time, all of the things that are going to form stable molecules in solution, form stable molecules in solution. So if we're running a very long maturation process, we often find that the filtration is easier than if we run a shorter winemaking process, simply because those reactions might only be partially complete with a shorter process. I mentioned before the intensity of the extractive processes. So, how extractively we work. Next is dimension of settling and maturation vessels, which is a really very basic thing, but has a huge impact on filterability of wines. If we've got an insulated tank that is very, very tall and thin, we have excellent stratification of solid and liquid. But if we have the opposite of that, we have a very poor stratification, and the next stage in the winemaking process is then really difficult. So it's for that reason that often wineries might have designated tanks specifically for the purpose of settling prior to filtration. Other inputs winemaking inputs that would make a difference would be things like utilisation of fining agents and settling aids. So many fining agents, which we talked about last week, have clarification impacts as well. So bentonite, for example, is a very good clarification agent. So not only does the bentonite react with the excess protein in white wine and rosé wine, it also assists in settling out larger macromolecules to the point where we can be, we might find ourselves at 2 NTU in a well settled tank. And if our goal is to achieve sterile filtration, which is giving us a turbidity of 0.45 NTU, we're most of the way there. So the use of fining and settling aids can make a very big difference to the filtration step. Next, we talk about the stability of the cellar temperature. So where we have variations in cellar temperature, what we have is a difference between we have a high thermal mass in our tank, so and then we have changing air temperatures. So we end up with small convection currents inside our vessel that continuously disturb the lees and make the settling process take a much longer period of time as a result. So quite often where we have a cellar that isn't ideal, and most cellars in Australia probably aren't ideal, to be honest, the location of those vessels is sort of given the highest status. So it might not be the tank beside the roller, or it might be the tank at the very back of the cellar, and that improves the settling. Next, consumer expectations, which we've touched on sort of many times, I guess, throughout this subject. What are people expecting from this beverage? And yeah, I think that's I guess where winemaking interfaces with marketing. What do people expect? Traditionally, certainly, there's been a high expectation for very clean, bright wines, free from hazes and deposits, free from brown hues in white wines, free from browning in white and red, really, and filtration helps achieve that objective. Okay, next we'll go through some of the most common filtration methods. Any questions? Let me just pause for a moment and give you a chance to ask some questions.
Just a question about timing with maturation. If you were going to age a wine in barrel for a significantly long period of time, would you do the filtration after that or before?
So generally, wines would go to barrel unfiltered, simply because over time, the involvement of all of those macromolecules and the reactions that take place with anthocyanins, so our colour, and tannins, which is our textural part of that equation. Those reactions take quite a long time, and that's in essence what maturation is. So if we make the wine too clean too soon, we're removing a lot of the wine components that will potentially contribute to the maturation process itself. So what we want is, those anthocyanins and tannins to form strong, stable bonds. We want those tannins to polymerize and soften. So if we carry out a process that removes those compounds when they're in less stable molecular forms, we potentially limit what we can achieve during the maturation process. But there are exceptions to that, which is why it's a really good question. There are, for example, where a wine might be at risk due to a very high pH that can't easily be remedied. So, for example, where, a traditional thumb lock, if you like, is where you have a very high pH and a high TA. So in that situation there, the wine is already tasting quite acidic and is at risk. And so the remedy can't be to add more acid, because it will make the wine, undrinkably acidic. So in that situation there, risk management would consider things like lowering the temperature of that wine during the maturation process, having a high amount of tannins in that wine, which would act as an oxygen scavenging agent. And filtration would also be a tool that we would consider for making that wine safer during maturation. And in terms of Luke's question, so does filtration strip out much of the good aromas or complexity of the wine? It's a really, really interesting question, and it's probably quite a divisive question as well, because there are many wine, people quite often almost form ideological positions on this question, and I think really the answer to it depends on what you're taking out by filtration, because sometimes when we filter a wine, what is retained, or in crossflow we call that retentate, but what's being retained and expelled quite often have less attractive aromas than than the wine itself. So we're taking something out of the wine that makes the wine smell less attractive. Whereas I think if what's being taken out smells more attractive than the wine itself, then maybe that filtration is having a damaging effect. But in general, wines are improved by filtration, because what we're taking out are most of the compounds are grape derived, partially broken down sort of bits of skin that have been floating around in this alcohol solution. So when we take those sort of chunks out, we find the wine looks brighter and fresher and cleaner. And in terms of that ideological conversation around filtration, it's very important. This is the most important point, that we're not putting anything into the wine, we're taking things out. So we're not making additions, we're not compromising the natural integrity of the beverage through, adding all sorts of dodgy crap. We're just taking stuff out that was naturally part of the wine in a it's a relatively low intervention process. We're not adding, nothing's being added to it. Whereas your comment there about light egg white, some fining agents, which was last week's topic, do have that's an additive that it's a production aid, but you can't argue that it's not an additive, because when you're putting egg in, even though that egg is not soluble and ultimately falls out, egg has a smell, egg has a taste, and likewise with milk fining or I'm trying to think. Some of the gelatin products, for example, derived from isinglass. It can often have a very fishy smell. So that's a swim bladder from a fish. Isinglass can be notoriously fishy at times, and so those steps will potentially tarnish the aroma of a wine. Whereas filtration is not adding anything; it's taking out. So filtration won't add off flavors, it will just hopefully remove them. Okay, so some different filtration methods to start off with. So centrifuges are something that were quite common 20 and 30 years ago, and are less common now. But I think due to the low rate of capital item turnover in wineries, we find, there's always something from 20 or 30 years ago sitting in the back corner. So you will still see centrifuges around. They work by imparting centrifugal force on our wine, and the heaviest particles move to the outside of our spinning cone, and then the clean wine is able to be siphoned off from the internal part of the centrifuge. One of the downsides of this process is there lots of rapidly moving parts. There's huge kinetic energy being imparted upon the wine, and the wine, goes. You've all probably heard the term bottle shock. Well, the shock that a wine suffers at bottling is also suffered along the way in these other steps as well. And this is a process that has quite a high level of shock on the wine. And this is probably due to very high dissolved oxygen pickup and just the huge amount of kinetic energy that's imparted on the wine. And for that reason, centrifuges are rarely used at the boutique end of the winemaking industry, and tend to be a technology that's used in larger scale commercial winemaking. Next, we have earth filtration, which has got a very, very long history with wine. Throughout the centuries, winemakers have been aware of the positive impact of some earths on wine. And, for example, bentonite that we discussed last week is an example of that. Diatomaceous earth filtration involves coating a filter screen, so a very tight mesh with diatomaceous earth. And then the diatomaceous earth has got a charge on it, and as do many of these other filtration media, by the way, which we'll come to in a moment. And as the wine passes through that earth, the charge facilitates the adherence of these particles to the earth. The earth is then replenished with a dosing pump that continuously puts new layers of earth on those screens, and that new layer of earth is then able to continuously react with the new wine that comes through. There's lots of limitations to this method of filtration. Firstly, the particle size of the diatomaceous earth. It's very difficult to perfectly homogenize a natural product to a perfect particle size. And it's for that reason the filtration grade that we achieve would almost have to be assessed on a batch by batch basis. Secondly, another limitation is the diatomaceous earth the particle size is extremely small and can very easily form a large plume in the air. If you just dropped an open bag of diatomaceous earth on a concrete floor, for example, there'd be a giant plume of tiny diatomaceous earth particles moving through the air. These particles can then adhere to your throat and your lungs and cause long-term health issues. So it's for that reason that when working with diatomaceous earth, we use PPE. Here's an example of an earth filter. So this round chamber, can you guys see my cursor there? This round chamber here is where our screens are located. And this chamber over here is where we pour our diatomaceous earth in. So our diatomaceous earth is mixed with water in this chamber here to sort of a homogeneous sort of liquidy paste. And then it's pumped or cycled through, layering the screens to the point where those screens have got an effective layer of earth, and then the wine filtration begins. And what has to happen prior to the commencement of filtration is that earth has to be rinsed of its earthy taste. So, I mean, not surprisingly, earth has an earthy taste, and where that earth is not rinsed properly, the wine picks up a very, very earthy character from this method of filtration. A limitation of this method is, can I just get an indication? Can you see this cursor moving? Yeah, great, thanks. So if you can imagine inside this chamber here, there's a whole series of plates, you know, going this way. They're quite tight, they're quite tightly packed. So another concept with this kind of filtration and others like it is that the rate of filtration is a factor of the filtration area. So if you want a fast flow rate, then you have a large surface area of filtration media. And so to achieve that large surface area, this chamber has got many, many plates laying across it. And as we continuously coat each of these plates with earth as we're filtering, gradually those layers of earth build up to the point where they're nearly contacting the plate above. And at that point in time, this chamber here is entirely caked with earth, and filtration has to stop so that the plates can be cleaned off and the process started again. So there's a certain capacity that these machines have, and that capacity is obviously determined by the size of this chamber here. Any questions on earth filtration? Okay. Yeah, thanks, Aaron. So earth filtration used to be the main method of filtration because the earth was extremely cheap, and those many handled contraptions weren't overly expensive either. But it's there. In the end, probably what finished earth filters off as a mainstream method of filtration was the danger around working with diatomaceous earth, plus the limited volume you could get through a machine. So, you might find that a machine like that, you might only get 10 or 12,000 litres filtered in a day, which for a small wineries find it, for larger wineries is too restrictive, and they might have to have multiple machines running. So next, well, not next, but plate and flame filtration is another variation where what we see is those screens, instead of being horizontally mounted in a stainless steel chamber, we have them vertically mounted in a frame. And instead of earth being the filtration media, we're using cellulose pads. And cellulose, prior to cellulose being the filtration media, I think in the late 1800s, asbestos was used, and obviously health concerns around the use of asbestos led to a replacement with cellulose. And the way this method works is our pads have got a particular pore size. So the way the cellulose pads are made is they're essentially laminates of cellulose fibers, and how tightly packed those fibers are determines the pore size of that pad. So if they're very, very tightly packed, then they would only allow through very, very small particles, and if they're very loosely packed, they would allow through larger particles. And what happens with this method of filtration is that the wine is pumped to the point where it interfaces with the filter pad and is forced through the filter pad at pressure. Very small particles are able to make it through those pores, and very large particles block up those pores. So over time, we have an increase in pressure and a decrease in flow rate through the plate and frame filtration method. Some of the problems with this method relate to that method of filtration. So over time, all of the pores that we had begin to block up. The pressure increases, the plate and frame starts to leak to a greater extent than it did early on in the filtration process, although they can leak very early whilst the pads are swelling as well. And gradually the flow rate diminishes to such an extent that we stop the filtration process, pull out the old pads, put some new pads in. And like with earth filtration, the filtration media itself represents a potential contaminant. So as we talked about earthiness with the earth filter, we talk about paddiness with the cellulose filter pads. They can quite often have a papery, a wet paper aroma that has to be removed prior to filtration. And this is done by cycling sulfur and citric through those pads for 15, 20 minutes, 1 hour, depending on how long it takes. And that's where our sensory skills come into it. So when we were preparing the filter frame, we would taste the water periodically to see how paddy it was tasting. And if it was extremely paddy, we would ditch that batch of sulfur citric water and run another batch and continuously do that continuously until we had just a plain citric water taste coming out of that machine. So here's what they look like. So these are the cellulose sheets in between these plastic sleeves, or here we can see them expanded a little. We have wine going in. There's only one path possible. There's only one path possible. So, and that is to go through the internal part of the plate and then be forced through the cellulose and then out another plate and then out the outlet. So putting these together requires, I wouldn't say a high level of skill. It takes a high level of care. So the positioning of the cellulose sheets such that there's an even edge on the top and the bottom is one part of it. And that's facilitated by there being little hooks on the bottom of each of these frames. And when we can come back to Epping, I can show you an example. Well, we can have a look at one of these and you'll see what I mean. The other part of it as well is making sure that at the top and the bottom, that the holes that allow the flow are perfectly lined up as well, so that there's no leaking on the inlet or outlet of the filter. This tray that we see here is a drip tray, and it doesn't matter how well you set up these machines, there'll always be liquid that doesn't move completely through the cellulose sheet. It actually falls off the bottom of the cellulose sheet into this tray here. So the liquid that we find in this drip tray is highly oxidized compared to the wine that's moving through the system. And so quite often, depending on the rate of dripping, a decision would have to be made about the volume about what to do with the volume in the drip tray. If it's only a bucket across a whole tank, you would probably just tip it out. But if it was larger than that, you might make a decision about either sulfuring that volume and downgrading it or reincorporating it into a lower value wine or whatever. But either way, it's a feature of this filtration mode. Okay, so next we move into a more modern method of filtration. Hang on a moment, I've got a fire alarm going off. Sorry about that. Okay, now, so membrane filtration. Bear with me. Okay, so the limitations we have with both of those previous methods is that the surface area of each of those methods is relatively simple and limited. A more complex way to achieve the same result with a similar approach is with membrane filtration, where these are manufactured in a more complex fashion where we have more uniform pores, and that uniformity in pore size gives us a more guaranteed result. Further to that, the materials that are used are able to have a particular chemical charge that facilitates filtration as well, and the housing that these membranes are encased in, as with the others, can have pressure gauges that can kind of give us, I guess, a more predictable lead into the end point of the filtration. So when that is when the filters begin to block. Let's have a look at a couple of examples of membrane housings. So each of these housings on the left here might hold 2 or 3 of these cartridges shown here on the right. What we have here is a material that's spun very, very tightly around around this bayonet that screws into the housing, and it's just the sheer surface area of filtration media is much greater. The quantity of pores is so much greater that they take a lot longer to block, and they block at a more consistent turbidity. So these might be rated to, say, for example, 2 micron, and you could be very confident in an absolutely rated membrane that there's no particles greater than a certain particle size that make it through these cartridges. But again, the issue with these cartridges is that there are a fixed number of pores in a particular cartridge or membrane, and once those pores have been completely blocked, there's no path for the wine to weave its way through, and our pressure goes up, our flow rate goes down, and then again there's a need to change the filtration media. Here's a cross section of what I was talking about before. So you can see there's a core, and the material is spun quite tightly in a complex fashion around, such that there's a huge number of pores contained within the cartridge. We should probably do this one. I'll do RDVs now. So rotary drum vacuum filters are a method of filtration that in many ways is similar to earth filtration, except all of the earth is dosed prior to filtration commencing. So this giant round drum has a vacuum that sucks the earth onto this exterior screen, and so this exterior screen can hold a certain quantity of earth. We then pump our wine or juice, they're predominantly used for juice, into this sort of giant bathtub at the bottom, and then the drum rotates through that bathtub, and as the vacuum continues to draw, it draws the juice through the earth, and all of the solids adhere to the earth, and all the liquid passes through and out. And as it continues to spin around, all the fouled earth is shaved off the drum with this giant long razor blade here and goes into a bin. And the fresh earth then contacts with the juice or wine below. And this is a really good method for reclaiming juice from tank bottoms. So when you'll recall when you racked your demijohn, there was some volume left at the bottom of it. Save that volume across a large commercial winery, you'd actually end up with it's something like 6 or 7% of your juice starting volume. So that's potentially quite a large saving. So that's why these machines were invented, and it's the predominant use for these machines. Okay, so next we're going to move on to cross-flow filtration, which is different to all of those other methods because the flow of the liquid is not crashing. We're not permanently blocking pores in our filtration media. The flow is across our filtration media, as illustrated here, And what we find is where we have the high velocity flow moving this way, it's that high velocity, high pressure flow of dirty wine that dislodges particles from our filtration pores, and the clean wine is able to move across that boundary, but the particles are not able to move across that membrane boundary. Illustrated better here, actually. Yeah, so comparing the two methods. So the traditional method, fire out particles, eventually block up our pores, have the wine move through, and then in crossflow we're going across the filtration media with a pressure gradient on either side. So we've got high volume, high pressure on this side, and on this side here we've got very low. We've got a lower pressure, so we have the clean part of the wine is able to make it across this membrane. What happens on the dirty side, though, is over time, this dirty side builds up with with very small amount of clean wine able to make it through, because the entire side of the filter is very high in particulate matter. And so what happens at that stage with cross-flow filtration is that dirty side of the filtration system is purged to a holding tank for filtration later, and then that dirty side is filled up again with clean wine, and the wine then cycles around and around and again. And it's that change. This drawing here in front of you now is sort of the essence of why cross-flow filtration is a superior method of filtration. So we're able to filter the wine for a longer period of time at a lower relative pressure, because we're not trying to jam wine through a foul filtration media. Here's what the machines look like. So they're relatively complex. I've lost my words. Our filtration columns on the left here reside in these chambers in here, and the wine is continuously pumped through those, and then on the internal of these media, our clean wine is removed out, or it's probably going the other way, right? Going inside to out. But it's moving through that media that enables the lower pressure on that on the clean side. Okay, any questions? Okay, I guess the final thing I'd like to talk about is the notion of filterability. So how do we know what wine will go through what filter? And the answer to that is we become familiar with the concept of turbidity and particle sizes. So what we can find is that we can have two wines that look a similar clarity that have very different compositions in terms of the molecules that are to be filtered inside. So we might have a very large number of very small molecules in one wine that would easily go through a coarse filter, but struggle to go through a very fine filter. And then another wine might have a very small number of large molecules that might initially foul the filtration media of a conventional filter, but then pass very easily through. Those large molecules would foul the surface of any filtration media, but there's only a small quantity of them, versus the other scenario where we might have a very, very large number of small molecules that might pass through a large pore size very easily, but not through a tight filter. And it's for that reason there that we need to talk about filterability. So what will happen to the filtration process as it proceeds along? So will our flow rate through the filter at one point in time be the same at another point in time? And that's what filterability is. And generally what bottling facilities that bottle a lot of wine do is they would measure the throughput of, say, a litre of wine through a laboratory scale filter at, the 60 to 90-second mark, and then they would wait another minute and then measure that filtration rate at, say, 120 to 150 seconds. And they would equate the throughput they achieved in the laboratory with their filtration on the bottling line. And from those numbers, they would be able to determine what wines can go through what filters. And that's particularly important, because one of the main concepts that we deal with next week in bottling is that at bottling, most of the bottling lines have inline filtration. And when we filter at bottling, we don't want to filter the wine to a greater extent than the wine has been filtered in the cellar, because we don't want to run the risk of having throughput issues at bottling. So we don't want to run the risk of varied output at bottling, because we find that throws out, that potentially impacts on fill heights on bottles and various other things. So bottling has got to be a very orchestrated, continuous process as best as possible. And if the filtration doesn't align properly with that, we find that the bottling process is messed up. So with filtration, what we're aiming to do is, at the end of the process of filtration, we want to have a wine that looks like we want it to look in bottle, because the bottling process won't change that any further. Okay, so so Rebecca's asked the question: when there is a blockage, do they just pause the process and clean the filters and continue on? Well, with all methods of filtration, there are no methods that are completely continuous. So even cross flows, as good as they are or not, they don't run forever, simply because eventually the pores of the cross flow become too blocked and have to be, and the filtration has to cease. So when there's a blockage, what would happen is, ideally what would happen is the winemaker would be have some idea as to when that blockage is going to occur during the course of the day. So the aim might be, for example, to bottle 2 wines without incident, and then change the filters, put the new filters in, rinse them, prepare them, and start the next wine. But what can happen is that midway through a wine, the filters become too blocked, and at that point there, you would detach from the tank that you were filtering. You would put the suction end of your hose into some water, and you would push the system through, so that you could then push whatever wine was in the system left through to the delivery tank, and then you would then break that filter down and clean it. And the issue with that is that when that happens, there's mixing of wine and water in that process of pushing through that causes a greater volume of wine to be lost. And if you have to do that once in the filtration process, there's a certain loss associated with this step. So say, for example, a filter like we have in front of us there, that might have a system capacity of, 120, 150 litres, right? So the loss you would expect from that system would be the system capacity. Now, if you have two breakdowns, if you like, because the wine's not ready for that greater filtration, you would then have double the loss. So instead of losing 150 litres, you would lose 300 litres. And the idea of, knowing what you're filtering and through what is to minimise that loss, because if it's run well, you might have a loss of, with a crossflow, you might have a loss of like 1%. But if you're using a plate and frame filter and you have to stop 2 or 3 times, you might have a loss of 5 or 6%. So there are financial implications from messing up filtration that can be avoided. And having to stop midway through a job to change filters, is the source of that loss. Hope that answers your question. Okay, so hopefully you have all seen the video that Silvana took of me doing a sulfur check last week. On Monday, we're going to make another video on how to do some stability checks. And then the week after that, we'll make a video on filtration. So hopefully every week on the Monday, you'll have a video posted up that you can access on the topic of the week before. And yeah, there's no updates for you in terms of when you might be able to get back on campus. I'm checking in with Silvana every week to see if there's been any news, but at this point there's not. So at this stage, we have to assume that we're going to be continuing online indefinitely. And so, yeah, keep in contact. I'm going to be marking those first lot of assignments this weekend. And what happens then is those marks are submitted to the Trove for moderation, and then I'm given approval to release those marks after that process. So my expectation would be that you would be, if you've submitted those assignments, that you would receive them late next week. But yeah, again, if there's any change to that, you'll get an update from me. I'm really keen to get you some feedback as early as possible, because we're only got to bear in mind we're a month away from the large assignment being due, and then we're 6 weeks away from exam week too. So we're sort of coming into the business end of the semester. So hopefully you can have some degree of confidence in the way you're tracking, so that you can, yeah, approach those tasks with confidence. Any more questions?
Yeah, Mark, I had a bit of a question on sterile filtration, and I just wanted to know what sort of measurement makes a wine sterile, and what's the purpose of sterile filtering?
So sterile is, the definition of sterile is free from microorganisms, and to achieve that, the filtration media would have to be less than 0.45 micron in size. So that a sterile filter is a 0.45 micron filter, and the turbidity wine that's going through a sterile filter would generally have to start off at being less than 1 NTU in order to pass through that filter. And it's for that reason that, for example, the crossflow filters, the wine coming out of a crossflow filter is about 0.28 NTU, which means that it can easily then pass through a sterile membrane at bottling.
Great, thanks.
A big part of this is just getting, you're now familiar with, SO2 levels and what they mean. 10 is low, 50 is high, kind of thing. Well, now the next stage is to become familiar with turbidity measurements, what they mean. Like 1 NTU, it's a low turbidity and it's very close to sterile, and 100 NTU is a very cloudy wine, and getting a sense for how they look. So say, for example, a 20 NTU wine, could look cloudy or it could not look cloudy, because it sort of depends on, it depends on what's in there. But something that's 100 NTU looks extremely cloudy, and something that is 1 NTU looks extremely clean. So it's sort of, there's a bit in the middle there where the readings can be deceptive as to, how clean the wine is and the particles contained within the wine. But there's no question that, at 1, 2, 3 NTU, that the wine visually is extremely clean, and there's no question that at 100 NTU the wine visually is, murky and soupy and hazy. So it's another number to get familiar with, and then the other numbers to get familiar with are slightly more confusing, because the way filtration companies sell filtration media is they have their own numbering and lettering systems for different filtration media. So to some extent, it's a different skill to start, or different skills, and skills not the right word, but it's a different task to start learning what numbers from what companies equate to what turbidities, and that's just something that, if it's a skill you need, you'll acquire it, and if you don't, you'll acquire other skills, I'm sure. But yeah, it's just understanding what these numbers mean, I guess. Okay, I think that's probably the end of the topic then. So look out for some videos from me and Silvana late Monday. And if you've got any problems in the meantime, please get in touch. I'm about to post up something on the student wine now, so just it'll be just partly because it'll be useful to you guys. So for those of you that have added acid to your demijohns, for example, so the 3 demijohns that were left at Epping, I mentioned the TA was 7.6, so relatively high. So if you've added 2 grams per litre tartaric, for example, you would expect your TA to be not 7.6, you go 7.6 plus 2. So you might expect your TA to be 8.6. And that's why I think this information is useful to you. And then in terms of pH, we're not exactly sure what your pH would be with a hypothetical 2 gram addition, but we do know that it's going to be lower than 3.41, don't we? So is it going to be, the rule of thumb was 0.1 pH unit per gram addition. So does that mean it's going to be 3.21 or what? So the aim with me passing this information on is so that you can use it in your assignment to sort of make approximations about where you think your demijohn is and how safe you think it is. And then hopefully we can get you back in the lab sometime soon to actually do real checks. But till then, let's use that as a guide. Okay, everyone. See you next week. Thanks for coming along.
Thank you.